methyl. How many carbons were in the chain?
8.
How many carbons are in the chain?
8.
When we have 8 carbons and an alkane, what is the name?
Octane.
Octane. So, octane. This is the name of 3-chloro 3-methyl. Alright? So, that is it. So if you look at it, you realize that there is no space anywhere. Look at, after this methyl, did I write any other thing? There is nothing that separates letters from themselves. But numbers separates letters using hyphen. Alright? Why if you want to separate numbers from themselves, you use comma. Alright? So now let us do the second example. Alright, let's do the second example. Now, for the second example, let us get the longest continuous carbon chain. Alright? So, it's already clear. I'm looking at it, it's looking at me back. Okay. Is it not this? That's it, right? So, this is the longest. But you have to be very careful, even if it's looking at you back, you have to be very careful. Okay? Don't be overconfident. Okay? Be very careful. So, whatever is not in the parent chain is a what? Substituent. So circle it. So how many substituents do we have? 4 substituents. 1, 2, 3, 4. Alright? So how many carbons do we have in the chain? 1, 2, 3, 4, 5, 6, 7, 8. So it will be what? Octane. That will be the parent name, right? We'll come back to that. Let us now number it from the end that will give these 4 substituents the smallest possible number. Alright, so now let's do that, guys. Now if we start numbering from here, you have 1, 2, 3, 4. So 4 plus 5, right? 5 plus 5 plus what? 6. Are we together? We are numbering 1, 2, 3, 4. This substituent is at carbon 4. 5. These 2 substituents are at carbon 5. So 5, 5. This substituent is at carbon what? 6, right? Okay. Then so we have 4 plus 5 plus 5 plus what? 6. Which is what? 20, right? Let's check from here. 1, 2, 3. 3 what? Plus what? 4 plus what? 4 plus what? Plus 5. So what would this give us? 18, right? Will it give us 18? Okay. So 3 plus 4 is 7. Now 7 plus 4 is what? 12 plus 4 is 11. Now 11 plus 5 is 16, not 18. Alright, so this is the smallest, right? 16 is small compared to 20, is it not? So now it means I have to number from what? Here. Because from here that gave us the smallest possible numbers. So we'll say 1, 2, 3, 4, 5, 6, 7, what? 8. So now let us attach, just like we did to chloro and methyl, let us attach numbers to each of these substituents based on their position in the chain. Okay, let's start with this. It's 3 bromo, right? 3 bromo, 4 what? Methyl, another 4 methyl, right? And another 5 what? Methyl. Is there any other substituent? No. Is there any other one? No. But if you look at it, you realize that methyl is appearing how many times? 3. What did I say about substituents that appear 3 times? You use tri, right? You use the prefix tri, right? Beautiful. Alright? So, but we have to start alphabetically. Alright? And please, prefixes does not actually stand as a criteria for alphabetical. You don't use prefix, you use the substituent itself. So even if you're using, for instance, di, okay? You're using di. Let's say dipropyl. Okay? Dipropyl, listen, and you have methyl. Methyl will still come before dipropyl. Because it is the P in propyl we are looking at, not the D for di. You understand? So methyl will still come first before dipropyl because it's not the D. That's the mistake people usually make a lot. They feel that that prefix is usually a criteria for nomenclature, but it's not. It's not. So let's do this, guys. So bromo will come first, right? So this will be 3 bromo. Now, so this is what we'll do. We'll say 4, 5 hyphen trimethyl what? Okay. That's the name of this. Okay? 3 bromo, 4, 5. So it's 4, 4, 5. Don't say 3 4 methyl, 4 methyl, 5 methyl. No, it's not like that. It's not. It's not. It's not. It's not. Ask a question. Chlorine, bromine, and what? Alphabetically, now bromine will come before chlorine, now chlorine will come before iron. Right? Alphabetically. Do you see any capital letter here? No. Do you see any space? No. So that's it. Alright? So let's quickly name the last one. Alright? Although we still have more structures to name, but let's name these three that are on the board. Okay, we've named the first one, we say 3-chloro, 3-methyl-octane. The second one, 2-bromo, 4,4,5 trimethyl-octane. Let's name the last one. Alright? So, for the last one, if you look at it very well, you realize that even the straight chain is the longest. Yes. Are you seeing it? Yes. The straight chain is the longest. Alright? So the straight chain is the longest already. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It's not the longest now. We don't need to even check. It's evident. So when we have 6 carbons to an alkane, what is it called? Hexane. So this is a substituent, this is a substituent, this is a substituent, and this is a what? So we have how many substituents here? 4 substituents. So I look at this guy. So it means that the name of this structure would actually come after we must have numbered the chain. Right? Let us number the chain from the end that will give this substituent the smallest possible number. Right? So now let's check from this end. We check from here, we have 1, 2, 3. 3 plus what? 4 plus what? 5 plus what? 5. Because these two are carbon 5. We will start from here to be 1, 2. 2 plus what? 2 plus what? 3 plus what? Plus 4. So which one is obviously the smallest? This now. Do we even need to count? No. So this one is the smallest. Alright? So we have to number from here. Where did we get it? From here, right? Yeah. Good. 1, 2, 3, 4, 5, what? 6. Alright? So now let us attach numbers to our substituents. Let's start with this. We have 2 chloro, right? Yes. We have 2 fluoro. We have 2 what? Sorry? 3 methyl, right? And 4 what? Methyl. Okay? So it means that the name of this structure will start from chloro, right? Yes. So we have 2 chloro, 2 fluoro, 3, 4 what? 3, 4 dimethyl what? Hexane. Alright? So that is the basic pattern for naming alkanes. Alright, like I said, we'll look at complex ones, okay, in, of course, the next video, alright, but for these ones, okay, just understand that these rules applies to even alkanes, applies to alkanes, alright. If you understand the general rules for naming alkanes, then you will not struggle with complex ones. Is that okay? Yes. Alright.